for the next session, we have a really exciting one. It's Sandboxed JavaScript plugins. Oh snap, it's MetaMask. Olaf's going to walk you guys through how you guys can extend operations in MetaMask with JavaScript. So, Olaf, welcome.
Alright, I think we're ready. Please raise your hand if you can hear me correctly. Alright, all good. So I'm Olaf, I'm a tech lead at MetaMask, but I won't really be talking too much about MetaMask today. I want to talk about the technology that we're building right now and researching. So here's the mandatory social proof slide. It's always required, obviously. But what is the use case of the technology we're building right now? Well, we're building MetaMask Snaps. It's ability to allow you to extend MetaMask using your own code inside the extension. You could add support for Bitcoin, you could add support for your own blockchain, you could add support for notifications, automations, things like Zapier, and so on and so on. It's a really cool technology, and I'll show you a quick demo of how it works, so what you can understand what we're working on right now. So this is an old demo of a Bitcoin snap, where you have a website that connects to MetaMask. Sorry. The slides broke. Let me go back. There we go. It's a Bitcoin snap that you can connect to MetaMask. So you unlock your MetaMask Flask, which is a canary release of MetaMask that we do feature testing, and that's where the snaps is currently. We're going to be stable during this year, but for now, if you want to play with it, you have to install Flask. So now the website is trying to connect to the extension. The quality is not great. Let me see if I can get the quality better. Right. That's not perfect either. But what you can see in the top right is the permission request. So the website is requesting the permission to connect to MetaMask. So we as the user approve this. And now what happens is we fetch the snap from an external sources, in this case npm, and now we're trying to install the snap in the first place. The snap is requesting multiple permissions. It wants to display a confirmation in MetaMask, so a pop-up window. It would like to access your private keys. This is important. Private keys for Bitcoin and Bitcoin test networks. This is a very security high risk. Do we want to allow this or not? So the user is aware of the risks and is okay with sharing the private keys for Bitcoin. Notice that we don't share Ethereum keys or your master key. We share only the specific coin type private key, only if the user approves. So now the snap is installed, the website is connected to MetaMask, and is talking directly to the MetaMask snap. So now the website would like to get the public key and get the addresses of your Bitcoin wallet that is living inside of MetaMask. And so now how websites could connect to Ethereum, you can also connect Bitcoin websites to MetaMask in the same way. You can send transactions. As you can see, there's also a confirmation window before doing any destructive transactions on our side. can receive Bitcoin normally. And so on and so on. But I promise you I wouldn't be talking about MetaMask. What I want to be talking is how you can build a sandbox of your own. So we're sharing the private keys with our code from external partners, right? So how do we make it secure? Here's an example of what we would like to have. We would like to have a plugin, external plugin that supports Bitcoin. You can see it's Bitcoin because it's BIP 122 specification, right? So the Snap would have the ability to get accounts, other accounts, remove accounts, sign transactions, and so on. But we also want to integrate the Snaps into the main MetaMask UI. Here, for example, like whenever a transaction is coming through Ethereum network, we would like you to have the ability to, for example, do risk detection, fraud detection, get some useful information to the user, right? So when the confirmation screen pops up, you get your own Snap tab where you can add information or manage the transactions on your own. So now the user is able to extend their own wallet on their own without us needing to build the features you requested. Alright, so this is the end goal. How do we get there? What is the technology behind all of this? How can you build your own plugin system? This is what we would like to do in theory. We want to fetch some source code from an online website or whatever source you want. And we want to just run it. But man, JavaScript has its quirks. So eval is not secure. Eval allows you to access the global scope. You can access the console. You can access all the variables that are declared in the scope that the eval is run, which is really not great for something as secure as a wallet. So we've been working for many years now on Secure EcmaScript. The goal is to have it inside the JavaScript as a language. So we work with TC39 to get it specified. But currently we have a polyfill called Secure EcmaScript, or SES for short, that you can install. This is an ongoing research on security and sandboxing inside JavaScript using only JavaScript, which is run by both MetaMask and arbitrary cooperatively together. So looking at the previous example, on line 1, on line 5, and on line 6, you have new information. So you import SES, which is a polyfill, and now you have a new object called compartments. And now compartments allow you to evaluate the code inside that specific compartment with that specific compartment state. So now, as you can see on line 6, when you evaluate the same code that we evaluated before, the console is not defined, the recovery is not defined. This is magic, it really is. So I'm going to be stepping through all the steps that you need to build your own SES. As a compartment has its own state, you can inject scope into it. So for example, in this case, we want to inject a global console. So now the code running inside the compartment, it has the ability to use the console log, only if we allow it to. That's how we allow the snaps to communicate as well. So what we do is we inject the APIs into your plugin. So you can have function calls, you can have methods, you can have properties, anything you like. And now not only you have on line 8 access to console log, but now you have some kind of API that you can design. But JavaScript has its quirks, so those things that are passed down to the compartments, they're not really passed by value, they're not really passed by reference either. But what can happen is a bad actor, a bad plugin can modify the properties of the objects passed down. So that, as you can see on line 9 and line 10, we have two different compartments that they should, in theory, be separate from each other. But because we're passing the same API object, the object is modifiable. So now compartment A can communicate with compartment B using a side channel of modifying the properties of the API object. Well, we already thought of that, as you can see. So how do you secure about this? You have the we create the harden function. What the harden function does, it takes an object and freezes it, meaning no, you can't rename or add or delete properties from an object. But we also traverse the whole property chain of that object. We go deeper into each property and we harden each property as well. But we also go above to the prototypes of the property. So we traverse the whole hierarchy. And so now that we harden our API object on line 7, now the compartments A and B on line 12 and 13, they can't communicate anymore. So when on line 12, the compartment A tries to modify a property, it's just a no-op. It does nothing. So now we remove that side channel. But man, JavaScript has its quirks. So intrinsics, arrays, maps, sets, all those stuff, it's all modifiable. It has its own properties. So you can get an array, and then you can get the prototype array, meaning the array that creates all the other arrays, and modify its properties. So now you have a side channel again. This isn't great. So what can we do about this? Well, we can lock down the whole JavaScript engine forward. So we get all the intrinsics. We get the arrays, we get the sets, we get the map objects, we get a lot of stuff. And we harden and freeze each and every one. There is a lot more complexity involved behind the scenes. Some stuff is removed, some stuff is added. But for presentation purposes, that's pretty much what it does. And so what you can see on line 11 and on line 12 is you don't have a side channel anymore. But man, JavaScript has its quirks, so there's a lot of ways to escape the sandbox. For example, if you set a timeout in your own scope and then you want to clear the timeout inside the sandbox, the clear and set timeout just take integers. So you can take an integer, input it, and you can clear timeouts that you don't really shouldn't have access to. The errors have a stack trace, meaning you can get random entropy or you can see what is happening behind the scenes. The import is not a function. Import is a built-in, and it's really hard to get rid of built-in. You can't just remove it or harden it or do anything with it because it's literally part of the language. You can use date now to have timing attacks and recover passwords because checking passwords it depends on the amount of time that takes to encrypt that password. You could have map random, which is depending on the browser. The state of randomness is per tab, but also it could be per origin, it could be per whole window, and it really depends on the browser. So now you could have side channel communication between snaps in different tabs that can try to talk to each other using this internal state of randomness. And there's a lot more stuff, promises, fetch, WebSockets, there's a lot of stuff that we have to harden to make everything secure. Alright, so this is what SES does. I promise you that you will be able to build your own SES from the get-go, from zero. Man, JavaScript has its quirks. Have you ever heard, who has heard of the with statement? Can you see your hand up? Alright, so with statement is a very niche thing in JavaScript. It's so niche thing that if you use TypeScript or use strict, which is now mostly recommended best practice, you can't use with keyword. It's not possible anymore. So what does with keyword do? Well, with keyword replaces the global namespace, or more like prepends the global namespace with the object that you add to it. So in this case, on line 4, we prepend the global namespace with the map object. And now on line 5, 6, and 7, you can access map.p, map.cosinus, map.sinus without saying that you're accessing the map object. So what happens is very similar, for example, to a bash path object, where when you try to access some kind of item, such as p, first it checks the map object. If it doesn't find it in the map object, it traverses the global scope downwards and goes through window, self, global this, and so on. So as you can see, we can access map p, but also we can access the r, the radius. It all works together. I can see why that was removed and why it's confusing. There's also another fun thing in JavaScript called proxies. So proxies allows you to catch all and every access to an object. So on line 1, we create a new proxy. We give it an empty object, those curly braces. And we provide the implementation of the proxy hooks. So now, when you try to access this new proxy that we've declared on line 10, namespace.a, first the function called has on the line 2 is gets called. So the target is the instance of the object. In our case, it's an empty curly braces object. And with a string key, in that case that would be a. But we also, we want to say, this object contains everything in the world. So we always return true. Right, so now we know that this object contains a. But now, what happens when we try to access a? And this is what the callback on line 5 gets called. The parameters are the same. And in this case, we just return the key, which is the string property. So now, whenever you try to access properties on the object namespace, you're just going to access the string value of the property that you had. Well, JavaScript has its quirks, and you can connect those two things, and you get really crazy stuff. So now, because we can use the with keyword, and we can create a new proxy that says, I have every object in the world, and you return those objects as strings. Now, whenever you try to access a variable that doesn't exist, it's just going to be a string. So now you have pair words in JavaScript. Alright, we can use this, we can leverage this, we can make a sandbox out of this. So, we have those endowments I talked about before. We have the console, we have the API, and we can inject it into a proxy. So now, we have a proxy that always says that all the objects are rare. And whenever you try to access an object, it's going to try to get it from the endowments. If the endowments has that object, that's great. It's going to return whatever you injected into it. If it doesn't, it's just going to return undefined. As you can see on line 8, we tried to access date. So namespace said, yeah, I have date, but then the date I have is undefined, so I'm just going to return undefined. But then on line 10, we try to access console and we try to access API. And we have those defined on line 1 and injected on line 2. So now, yeah, we have console log, we have API, so now it gets printed into console. But man, JavaScript has its quirks. So the this keyword, oh my god, the this keyword. So when you try to access the this keyword outside of a class, it's just going to return the global object. If you try to access in the function, it's going to return whatever the function desires to. So you can escape the sandbox using this. But what if we wrap the with keyword inside a function and then we apply this, right? So functions in JavaScript can replace the this keyword with whatever we want because JavaScript has its quirks. So now we replace the this keyword with our previously defined namespace proxy. And now when you try to access this, you're just going to access the same global scope we defined before. But man, JavaScript has its quirks. So as you saw before, we can't use strict. So if you're not using use strict, if you try to access an undefined variable and write to it, for example, our variable on line 3, outer scope, and write to it, hack, now that variable gets created automatically with no error in the global scope of the whole system. So now you can rewrite our own properties that the plugin should be able to access. This doesn't work in use strict context, but it works in normal JavaScript. So what can we do to use strict? Well, use strict can be used in two places, on a whole script file, but also on a specific function. So now we have this function that we had with keyword, and we wrap it inside another function as well. So now the plugin is run inside a function that is strict, that is called from a function that is not strict, but has the this keyword replaced. And when you combine those two things together, now you can't use the hacks that were possible without the use strict. So now, if you try to write out the scope, that's not going to work. Right. This is the most important part. So let's make our own safe eval. This is a function we would like to replace eval with. It's gonna get a code, right? So normal code that you can run. And we wanna have the endowments, meaning the things that we wanna inject into the global scope. So now, as before, we create a namespace, but because we need to run the code in the first place, we need to inject eval as well. So as you can see on line 2, we have endowments, but also eval. You can see that the proxy object on line 3 and 4 doesn't really have a get function anymore, because proxy just assumes that if there's no get function, it's just gonna call the injected object. And if you try to access properties of an object that are not defined, it's just gonna return undefined. So the get function is not necessary. Eval runs the code and returns the result. So on line 5, we return the result of this huge messy function. So on line 9, we replace the hack of the outer scope with an eval. We return the result of the eval. In this case, this is unsafe eval that is run inside a safe eval. But wait, where did the code parameter go? It's not there. We're using some kind of arguments that we didn't declare that. So, because we're using the with keyword, we have the global scope injected, right? Which means inside the with this keyword, we can't access code, we can't access the endowment parameters. But what we do is, we call a function inside of it, and we can access the properties defined inside that function, which is arguments. So whenever you call a function in JavaScript, because JavaScript has squares, a new object gets created inside the scope of the function called arguments, which is just a list of all the parameters that was input into the function. So what happens now is we create a function that is strict on line 7 till line 10. We don't call it yet. It's inside an outer scope of with this keyword, which secures the global scope. And now we call two functions at the same time. So first we call the outer function on line 12 with the namespace as before. This returns the new created function. And then we call it the code parameter that gets input the arguments object. This is fun. Oh man, JavaScript has squares. So you saw that we inject eval now, right? So now the plugins have access to eval. Oh my god. So if you call eval, it removes the use strict requirement. So now you can access the outer scope again as if the use strict didn't exist in the first place. Okay, what do we do now? This is getting complicated. Can you see the pay? Oh man, I guess not. So, where were we? We create a new with on line 12. We inject it with eval once. So eval once is an object where when you try to access this object, it returns an eval, right? So on line 7 you have get, right? So you try to access an object, the property eval, you're just gonna get the eval. But then we use a nice trick of RI, prototype bind, and then the array. So bind removes the element from array and also returns it at the same time. So the first time you try to access eval1.eval, that's gonna return eval, the unsafe eval. But if you try to access the second time, it's just gonna return undefined. So because the with keywords prepends to the global scope instead of replacing it, we can join those with keywords twice. So first, when on line 15 the eval gets called, the with keyword on line 12 gets called, the eval gets returned. And when inside the eval on line 15, now it's going to be using the global scope of the line 11, which is this namespace. As you can see, like we have two items that we need to use. So this is why we're not using this inside the with keyword anymore. We're using this with two objects on line 19. and line 20. Right, so this is the final code, and if you try to run it, it's actually going to work, and it's actually pretty secure. I've tested each and every slide to be working on Node.js, so this is real code, and this is really how quirky JavaScript is, and it really runs. And this is pretty much the core of what we use to run snaps and plugins. I've added two new things on line 1 and on line 6. There's object that create null. So when you create an empty object, it has a prototype, which is the empty object prototype is the object. But if you create it with an object that create null, you set the prototype to null. So now, even if you forget to harden or lock down things, you won't be able to access the prototype of the endowments object or the eval_once object. And that's all I have. If you wanted to get in touch, find me on Twitter. And we have 4 minutes for questions. Do I see any questions? All right, then we're done. Thank you.